Visualize a colossal assembly, orchestrated by an infinite expanse of stars, planets, moons, and satellites, an eternal symphony of cosmic harmony stretching across the heavens. Each celestial body contributes its own note to this grand performance, creating a rhythm so vast that human imagination strains to contain it. And yet, within this orchestra of light and motion, there exists one section that has long captivated scientists and dreamers alike. One enigmatic mystery that refuses to remain silent: the exoplanets. Exoplanets are worlds that orbit stars far beyond our familiar solar system. They remain hidden in the immeasurable depths of the Milky Way, veiled in cosmic shadows, yet their presence is undeniable and alluring. Some of these planets appear strikingly similar to Earth, as though they are distant reflections of our home world, recognizable, yet shrouded in profound alien mystery. Among this vast multitude, one name rises again and again in both scientific research and public imagination: Proxima Centauri b. Situated a mere 4.2 light-years away, cosmically speaking, right in our neighborhood, Proxima b has the power to reshape our very understanding of habitability. Consider the scale. In a universe stretching nearly 93 billion light-years in diameter, finding a potentially life-supporting world this close is like stumbling upon a glittering diamond hidden within a mountain of sand. The Milky Way itself may host more than a quadrillion exoplanets. That is a 1 followed by 15 staggering zeros. To make that number real, imagine that every exoplanet was reduced to the size of a single grain of sand. Those grains would not only fill the vast chasm of the Grand Canyon, they would create a Grand Canyon 2.0, a second majestic wonder carved entirely from the fabric of possibility. And even more astonishing, nearly 20% of these worlds may be Earth-like, bearing familiar landscapes, terrains, and atmospheres. Encircling them may be an equal number of moons, each locked in gravitational embrace with its parent planet. Every moon, like our own, could be a potential stage upon which life might one day emerge. If you have ever dreamed of discovering another life-supporting oasis in the universe, the cosmos offers not a handful of chances, but a staggering ocean of possibilities. At the forefront of this exploration stands our most powerful instrument yet, the James Webb Space Telescope. A marvel of modern engineering, its segmented 6.5-meter primary mirror is 2.7 times larger than that of the legendary Hubble telescope. This immense surface grants Webb an extraordinary clarity of vision, capable of capturing the faintest flickers of distant stars and the delicate shadows cast by unseen exoplanets. But Webb is more than a telescope, it is a laboratory suspended in the emptiness of space. Equipped with advanced detectors and sophisticated spectrometers, Webb does not merely look, it investigates. It dissects light into its most minute details, unraveling the hidden fingerprints of atmospheres, elements, and molecules. Through this analysis, scientists can determine whether a faraway world contains water, organic compounds, or even oxygen that could sustain breath. The James Webb Space Telescope is no longer just an observer. It is an investigator, an analyst, a cosmic detective. It elevates astronomy from passive stargazing into the realm of deep inquiry. Since its discovery in 2016, Proxima Centauri b has remained one of the most compelling worlds beyond our solar system. Orbiting its faint red star within the habitable zone, it sits in that rare band of distance where liquid water could exist. Water that might pool into rivers, collect into lakes, or stretch into vast alien oceans. Picture this world. Rolling landscapes carved by unfamiliar winds, skies tinted by a red glow, and seas shimmering beneath a sun far dimmer than ours. Yet, for all its promise, Proxima b is not Earth. Its rhythms are strange. One planetary day lasts about 11 Earth days, meaning its sunrises unfold slowly, painting the horizon for hours, while sunsets linger in endless twilight. For humans, adapting to such cycles would be difficult. Would our bodies endure such extended periods of light and darkness? Would sleep and hunger obey new rhythms, or would we be forced to reinvent what it means to live by time itself? This is where the James Webb Space Telescope becomes invaluable. Suspended in the vacuum of space, Webb is not just an observer, it is a cosmic laboratory. By breaking down the light that filters through Proxima B's atmosphere, Webb can detect the fingerprints of molecules like carbon dioxide, methane, or even oxygen. It can reveal whether water vapor rises from alien seas or if conditions resemble those that once nurtured life on Earth. For the first time in history, we are not just imagining distant worlds, we are reading their atmospheres like open books. Then, something unexpected happened. Astronomers analyzing Webb's data noticed a peculiar signal. It was structured, deliberate, not the random static of space. For a brief moment, humanity dared to ask, was this a message? But just as suddenly as it appeared, it vanished. No repetition, no explanation. Was it interference? A natural phenomenon? Or something purposeful that we only glimpsed once? This mystery has fueled new ambition. Scientists now propose using Webb to search for artificial illumination, the faint glow of alien cities shining across a planet's night side. If such lights exist, even dimly, Webb's instruments might one day detect them, offering the first indirect evidence of intelligent life. Yet Proxima B is only the beginning. Across the galaxy, thousands of exoplanets continue to be discovered, many lying within their stars' Goldilocks zones. Some may host worlds far stranger than ours, places with methane oceans, skies filled with ammonia clouds, or frozen crusts hiding vast oceans below. Here on Earth, extremophiles prove that life is far more adaptable than we once believed. Microbes flourish in boiling volcanic vents, under crushing Antarctic ice, and even inside radioactive environments. If life can survive such extremes here, why not across the stars? With the James Webb Space Telescope and the growing power of artificial intelligence, scientists are able to sift through colossal streams of cosmic data, identifying patterns too subtle for human eyes. Together, they form a partnership of curiosity and precision, bringing us closer to a discovery that could reshape everything we know. And so the question remains, perhaps the most profound of all time: are we truly alone? Or is life, in its endless diversity, scattered like hidden music across the galaxy, waiting for us to listen closely enough to hear it?